Okay, so now we're coming to the next part, the second part of the week 4 lecture, and the topic we're going to cover in this part is going to be the teamwork in the engineering design. We're going to have some design brief and the settings up of the team, the managing of the project, and the demystifying of the design process. So we start with the teamwork in the engineering design. So here are some of the design brief examples we're going to talk about. Like for example, we need to develop a system for minimizing the household water consumption in suburban areas. The second example can be design of 35 feet sailing boats with accommodations for at least 4 people for up to 1 week of the cruising. Something like where to store the food, where to store the water will be enough for the 1 week of the cruising. Second, the design and an automated handling system for the transferring stamp parts between the processes in an automated stamping plant. Another example can be design of the small open wheel racing car capable of winning the FSEA events. So, mainly we're going to talk about the last one because most of the students basically going to try to work with this design, and I have actually no problem if the student going to have the same project in their final report. So the design brief questions are very important. You will need to ask yourself many questions about the design brief, like for example, who is the customer? What do they want? How much will they pay for it? And when do they want it? And do you have any competitors in this market? And what target will you set? And how can you measure the success of your design? And other questions that can be related to around the same topics. So the design mission statement for the spectacular this lamps are going to be first the product description, like standalone lamp for the disc use, what the brighting lighting is, funky shades can be used. Also the key business goals like the excite new market for the consumers, the primary market like the young professional workers, the secondary market is going to be for the students, and the stakeholders, which can be Western Sydney Uni student engineers design team, the lecturer and the tutors, and the Australian lighting manufacturers. So you need to identify the customer needs, like gathering the raw data from the customers. You can do that either by doing some interviews with the customers, make some focus groups, and observing the products in use. And to remind the customer needs for the data, from the data, like what and not how, the level of the need, the positive, not negative, and attribute of the products. Avoid the must and should. Okay, so for example, what not how is why don't you put the protective shields around the battery contacts? Or the battery is going to be protected from the accident shorting. Level of the need, I drop my screwdriver all the time. The screwdriver operates normally after repeated dropping. The positive, not negative, it doesn't matter if it's raining, it still need to work on Saturday. You will need still to work on Saturday. The product works on weekend. The attribute of the products, like I would like to charge my battery from a cigarette lighter. So the battery can be charged from a cigarette, from the car cigarette lighter. Avoid the must and should, like I hate it when I don't know how much juice is left in the battery. And you can say simply that the answer could be the product indicates the level of the energy in the battery. So identifying customer need also can be done by organizing needs of the hierarchies, like for example, categorize the needs into groups, consider creating super groups depending on numbers, review categories, do they seem correct or not. And also you can do the establish of the relative importance of the needs, like the consensus of the team opinion and use of the further customer surveys. Reflects on the results and the process. So, for example, have we actually interacted with the important types of the customers, and how can we improve the process in the future. So you can have a long list about the product, like can be the suspension and the need for this part and what will be the implementation of that. So for example, the suspension in the car to reduce the vibration on the suspension in general can be the need for it is going to reduce the vibration on the hands. So this can be implemented 3 points. Go to the other one, number 3. It's going to enable for the high speed descents on the bumpy trails. This will be more important, so this will be number 5. Someone told you, okay, now I need the suspension to preserve the steering characteristics of the bike. That's 4. Go to another important one, which is going to be 5. Fits a wide variety of the bike wheels and the tires. As easy to install, this is not very important. Works with the fenders, something like allow easy replacement of the worn part, but while it's not going to be contaminated by water, it's very important. Not contaminated by the grunge is going to be also an important point. Safe in a crash, last long time. So you can simply categorize the things for the customer needs, and then you can start to work to analyze them. Now we're going to establishing the product specifications. So what you're going to say that actually we need to prepare a list of the metric that will influence the product performance. You can use that as a benchmark for the other competitor products and set a target range and reflect and review. So it is vital that your design team develops a metric and targets. How else we are going to evaluate how good your design is the other way. So the design metric, once again, we are going to have the metric to be listed, the needs numbers, the metric number, the implementation, and the units we are going to have for this implementation. Like for example, I will take the spring preload. The unit is going to be Newton, of course. The needs numbers were 2 and 6 from previous list. And we can take, for example, the one of the important things like the wheel size. Okay, that's in number 9. And the implementation is going to be 5. And this will be actually done in wheel size, actually should be in inches. I don't know why it's written like that. The maximum tire width 5 in inches, and the time to assemble the frame is going to be 1, and this can be done in seconds. The motor cycles to failure, and this will be 5, and this will be considered by cycles and so on. So what we can do is that we can bring the two tables together, and we can have one matrix index about the needs and the matrix and the metrics. So we can simply just join between the needs and see which one is going to be the most important for our case. You can see that we have here from 1 to 26, and simply we're going to have them here from 1 to 20. Then we can connect with them and see actually how they're going to be a benchmark base for our design. So again, to go with the benchmarking, once again, the metric number, the needs number, and the metric, the implementation, the units, the standard track, the main number, the rock stacks, and so on. So we can build that according to the previous information that we collected from the system. From the survey, sorry. The target specification now can be analyzed. We can give a marginal value for each one of the metrics that we had, and we start our design according to that. Now, these are the target specification. We actually not going to work within this big range, so we need to do some refining for the specification. So we can do the refining of the specifications, like the develop of the technical models of the products, develop the cost models, refine and rationalize the target where necessarily reflects on the results. So we can simply going to have the model to assess the technical feasibility. We can use the suspended mass, the unsprung mass, the orifice diameter, the swing constant, the oil viscosity to feed the dynamic model of the suspension performance by doing the analytical one. And then we're going to get the output like the attenuation at the 10 Hertz and the estimated monster in grams and so on. So that's what we have. We're going to have an input, the output to be based on the input according to the analysis we're going to have for the dynamic model of the suspension performance. This can be something like a MATLAB Simulink model, or it can be just simple software where you can put all the information is, or the ANSYS model that you are going to build. And these are the data you are going to submit to and find what will be the output according to these parameters. So by refining the specifications, we're going to have the final specification list, and we can work on that. Now, you need to do that in teams. So we're going to need to build an effective team. So you need to define the clear roles of every team member, agree upon the goals, define the procedure, develop an effective interpersonal relationship, and define the leadership rules, because this will be very important. As a tutor or lecturer or a subject conveyor, I need to actually talk to a representative from the team who's going to brief me about the progress, tell me what they need to have as a help, what they know, what they don't know. Okay, so we need a leadership to do the work. The digital design project planning, where each member of the team should keep a logbook, each one, not single logbook. Put together an organizational chart. We need to have and arrange important milestones, dates on the timeline. Don't leave everything to last minute. 3 people in the group, that's when you can do the work as a small portion along the short time or the project or the semester. Then you can finish everything a long time before the end of the semester. So you don't have to rush in the last minute, try to ask for some extension for this project or any other project. So the organizational chart of the FSAA team, we have the faculty advisor, the team captain. We're going to have the chief design engineer, which is going to be responsible for the interior system, the powertrain, the driveline, the vehicle dynamics, the chassis, and the electrical system. We are going to have a person who's going to be responsible for marketing and promotion, and another person for the finance. Definitely, we're not going to ask you to do all this stuff, and design definitely not going to be that complicated. We'll try to get you some of these samples to show you what the other people done in the main campus in earlier semesters. So the design disk relationship, oh, by the way, for this one, you can also find your own organizational chart. The design task relationships, like the sequential, the parallel, and the combined tasks. So you start to build, the sequential one is going to be just following one into each other. The parallel, we're going to work as a team, 2 groups, to do the task to meet the final input. We can work as a couple task, so the parallel one can be joined together, so you can exchange the information about the compatibility of the 2 parts, or about the performance of each sub-team within one team to get the final targets. The time management, we can use the Gantt chart, and I think that you know what the Gantt chart is by now. We can use the Microsoft project to make the Gantt chart. You can even use actually the Excel to do the Gantt chart. But if you're actually going to search about how to use the Microsoft project to make the Gantt chart, it's going to be very easy to find multiple examples. We're going to show you, for example, what will be the task name and what will be the duration for this process, when you're going to start that, when you expect to finish, and it's going to schedule the Gantt chart for you. then you can link about, okay, now I finished this stage, I'm going to start the next one, I'm going to start the next one. I can jump from the input of the development of the team structure to go to the other one, which is going to be the use of the which is going to be the maintenance of the budget costing and extra. So you can see that these things are going to be connected together according to the need for that. The critical path is the longest chain of the dependent events, a single sequence of the event whose the sum of the duration define the minimum completion time, and that's it. If the task completion is going to be delayed and the task is a part of the critical path, then the completion time of the project is going to be delayed. So that's something we actually need to avoid. Okay, so the critical path method, or the CPM, well, network scheduling techniques are going to be often used in the project management to aid the planning and the control of the project. The networks are composed of events and the activities needed to carry out the project. The events are equivalent to the milestone indicating when an activity starts and finishes. The activities represents the elements of the work task and usually derived from the work breakdown structure that needs to be accomplished. So the critical path analysis is an essential project management tool that traces each of the major elements of the system back through the engineering of its constituent parts. So the estimates are going to be made of not only the size but also the duration of the effort required for each step. The path that is going to be estimated for the require the longest time to complete its constituted activities is called the critical path. The differences between the time and the times required between this time and time required for the other paths is called the slack for those paths. The resulting critical path network is a direct application of the WBS. Now, the critical path is the sequence of the activities with the longest duration, as we mentioned earlier, and delay of any of these activities will result in the delay of the whole project. So you can see that the top one is going to be the critical path analysis because it's the longest one. And if we're going to have any delay in the activity 3, for example, it's going to delay activity 4, and thus the whole activity of the project will be simply going to be slowed down. So these are the 3 paths through the project: start, activity 1, activity 3, activity 4, and finish. Start, activity 1, activity 3, and activity 4, then to finish. The other path is going to be start, activity 2, activity 3, activity 4, and finish. The third one is going to be start, activity 2, activity 5, and finish. So you can see that the longest one is going to be the second one. Going to have 1, 3, 4, and finish. So you will say, okay, now this one is also have 1, 2, 3, 4. But the activity 3 actually going to depend on the activity 1 and the activity 2 at the same time. So the longest duration of the activity is going to be the critical path. Also, we can check that by doing the calculation of the duration of the activities, like how many days. So the activity 1 is going to be 3 days, 7 days, and then 2 days for the 3 and 7 respectively. Total is going to be 12 days. For the second path, it's going to be 5 plus 7, that will be 12, plus 2 is going to be 14. For the third one, it's going to be 5 plus 4 is going to be 9. We have the float determinations. So after you identify the critical path of your project, you can determine with float of each activity. So the float or the slack is going to be the amount of the time an activity can slip before it's going to be causes your project to be delayed. Like for example, the activity 5 is floating for 5 days. So you're going to have 2 float here, 0 and 0 and 0. Now how we got that? Now we said that this link is going to tell me something, it gave me something like 12 days, 14 days of the accomplishing for the critical path. So for the first one, it was 12. So the difference between them is going to be 2 days. From here to the finish is going to be 9 days. So you're going to have the 14 minus the 9 is going to be 5 days float. The early start and early finish calculations. So simply by forward pass is going to be used to determine the earliest date and activity can start and the earliest date it can finish. And these dates are valid as long as all the prior activities in that path started on the earliest start date and do not slip. So starting with the critical path, the early start or the ES or the first activity is going to be 1, and the early finish or the EF or the activity is going to be its early start plus the duration minus 1. Or we can simply say that the ES is going to be equal to 1, the EF is equal to 1 plus 5 minus 1. And this will make it as 5. Okay, now once again you say, okay, now it's obviously going to be 5. Now just remember, just imagine that the ES is going to be 2. So this value is going to be 6. So you don't have to say, okay, now it's obviously going to be equal to 1. So now the backward pass is going to be used to determine the latest date of the activity that can start and latest date that can finish before it delays the project. So we're going to begin from the last activity in the path, where the late finish LF for the last activity, and every path is going to be the same as the last activities EF in the critical path. So the latest start LS is going to be the LF minus the duration plus 1. So the activity 4 is the last activity of the critical path. That's 1. So the LF is the same as the EF, which is going to be 14. Okay, you remember that this path was taking me to 14. To calculate the LS, okay, the latest start, we need to subtract its duration from the LF and add it to 1. So we have 14, the LF is 2, and plus 1, we're going to have 13 days as the latest start. Now, example of critical path analysis. We have a network map of the project tracing the work from the departure point to the final completion objective. So the duration activities, for example, the days are going to be 10, the final design is going to be 20, 30 and 40 and so on. So what we can see here, we can simply calculate what will be the longest path. We can know which one is shortest path. We can check about layout and other stuff. Now we can simply doing that, and the whole thing can be done by using something like the MS project. So if you're going to search for that, you can see that we can create a project and put all the information within. Like for example, you can have a critical path example using the MS project. We can actually share a video for you. So you're going to have a new project, time scale is going to be critical, and then you're going to have the intentions about the detail requirement, the hardware requirement, the final resources plan, the staffing, and you can add the duration in days with the date, okay, and then you can continue with that until you're going to have the final things to be done. Well, actually, I advise you to go through this link, and actually there are multiple videos that I'm going to share with you for this week. Just have a look. You're going to use it anyway in your project if you can. Example can continue with that. It's going to give you the Gantt chart for this process. It's Microsoft is available as a free license for the university students, so you can actually use that. And just remember that this stuff at the end is going to be an additive experience for you that you can use it for your career. The project management, once again, you can do the Google Project Management, and you can actually have the professional certificate for free by using the course here. So just go there, and I think it's still free. Yeah, enroll for free. Well, you're going to learn about the intention phase, the planning phase, the execution phase, and the project closure. In the planning stage, the SMART goals can be set to prepare the Gantt chart, which is something like when we call the SMART, which is the specific, measurable, attainable, relevance, and the time-based. So, for example, the design suspension for the car, you can do the CAD and the drawings in 10 days. The perform or the vibration analysis in the ANSYS, and you can get the result file for the suspension system in 15 days. And you can make the research and collect of 5 conceptual designs like structure, the image, 3D models in 5 days. That will be help you actually to make a successful Gantt chart for the project management. At any stage of the project, the triple constraint triangle should be maintained balanced. What is the budget, what is scope, what is schedule? For example, the original plan is to perform the vibration analysis, the topological analysis, and structural analysis in ANSYS. If it is dependent task, it will be delayed, then a change in the scope or more workforce are going to be a potential solution. So we're going to talk further about the project in next week, and also again to discuss that during the tutorial session. We will try to find some example about what we covered in this video, and hopefully it's going to be an easy task for you. Okay, so we done that. We did the computer-aided design, we did the teamwork in the engineering design, and you can read the lectures and the tutorial and the practice notes for this week. And next week we're going to talk about the digital manufacturing and the design DMD, and the reader is going to be lecture, the tutorial, and the practical session. Thank you very much, and see you soon.